All right, so now we have this problem, graph f of x equals -3 times cosine 2x on the interval from -2 pi to +2 pi. So this part right here, it's not exactly the same, but same kind of concept applies. We can just plug it into, or we can just evaluate this at certain points and go from there. So let's create a t-chart. Now notice this says we're going from -2 pi to +2 pi. So we can really just use the same 5 points that we've had and see if that does anything. It doesn't matter which points you pick, but normally with trigonometry, you want to pick points that that are easier to evaluate. And once you do this a little bit more, you'll start to see the pattern. So I'm just gonna do basically the negatives of these first values, which we did on the last slide. So our function, and maybe I'll just do the points on this slide, just evaluate, and then do the graph on the other side. On the next slide. So if we want to know f of -2 pi, that would equal -3 times cosine of 2 times 2 pi. -3 times cosine of 4 pi. -3, what is cosine of 4 pi? So that means 2 pi would be a full circle, and then another 2 pi would be another full circle. So it's basically the same thing as cosine of 0. And cosine of 0, didn't need to write that. Cosine of 0 is just 1, because the x-coordinate here is 1, 0. -3 times 1 is just -3. So we're going to put -3 right here. Okay? So now let's do the next one. And I'm not going to do all of these, but I do want to show at least some so you guys can see how to do it. So we have 2 times our x, which is -3 pi over 2. This becomes -3 times cosine 2 over 1 times -3 pi over 2 would be -6 pi over 2. -3 times cosine of -3 pi when we simplify. -3 pi, we go in the clockwise direction, so we start here, we go this way. But 3 pi ends over here. So it's going to be the same as the x-coordinate at that point. -3 times -1, which equals +3. So then this equals 3. And so if we continue like this, we'll get -3, 3, -3, and it'll just kind of repeat. Right? And notice 2 pi is the same as -2 pi. And I actually put I put -2 pi here, positive here, but it turned out to be the same thing. Notice this looks a little weird. And that's because we didn't choose any points that would cause this function to be 0. And of course we could do that, but then this list would just be, twice as long. All right, so let's graph this. So again, we want to scale our graph according to our points over here. So we know the highest we're going to go is 3. The lowest we're going to go is -3. So, it doesn't hurt to go by 1s. But let's say it was 12. Then you might want to go by 4s or 6s even, or 2s. But it's only 3. So, This is 3. This is negative 3. And our x-coordinate is going to look kind of the same as the last time, except I'm doing both sides. 3 pi over 2, negative pi over 2, 0, pi over 2. Alright, so first I'm actually going to just draw cosine. So that's what we had the first time. I'm going to draw this in green. So cosine did not start at 0. Cosine starts at 1. And it looks kind of like a V. So this is how cosine would look. And I'm trying to draw dots. It's not the best. But, you know, you get the idea. Alright, and so we're going to draw this function. And actually I'm going to draw the entire thing of cosine. So draw it on this interval as well. Just so we can kind of compare the two graphs. It's supposed to look curved. So hopefully that does. Yeah. Alright, good enough. So now if we draw this new graph, or f of x equals negative 3 times cosine of 2x at negative 2 pi, it goes to the left because it's negative 2 pi and goes down 3. So that's here. And then at 3 pi over 2, it goes up to positive 3. And then at pi, it goes to negative 3 and back. And 0 comes back down. And we just kind of follow this pattern. And if we connect it, and hopefully this turns out looking better, then, okay, not too bad, not too bad. Alright, so our new graph is in blue. Cosine was in green. I guess I can connect it. Doesn't look too bad. So, what do we notice? Well, one, the graph is stretched. So it's stretched from 1 unit. So the graph was just from here to here, but it's stretched from 3 to negative 3 after our transformation. And that's because of this number here, called the amplitude. So the amplitude stretches the graph. And also, it's negative. So notice that we started at positive 1 for cosine, but with our transform graph in blue, we started at negative 3. So the amplitude controls whether it stretches or shrinks, and then if it's positive or negative, determines the reflection. Reflection. And then, so the other thing is, if we look at this V, right, it's just one V, or we have two V's throughout the entire graph. But the blue line we have, so if it's upside down, we have 1, 2, 3, 4. We have 4 V's. And hopefully all these colors aren't confusing you or getting you off task. But that the amount of cycles, because one cycle would just be 1 V, but the amount of cycles that happen, that occur, the frequency is actually what it's called, has doubled. Is there anything in this function that we added that would double something? Well, there's 2. So this here is the thing in yellow is the period. All right, so the extra credit is this. It's for you to graph f of x equals 2 over 3 sine 1/2 of x. So you want to draw the table and then graph it and send me the graph. And actually try to show the parent function as well. So graph this as well as f of x equals sine x, so that hopefully you can see the difference between the two.